Okay, we're going to look at a couple of examples of modular encryption. Specifically, we're going to look at two of them today, or in this video. Addition being the simpler idea, and then also multiplication. We're going to save exponentiation for a later video. Okay, so this is the beginning of doing a little bit of our encryption. Okay. So I'm doing this on a Excel spreadsheet. As you can see, you can certainly do it you can do it on Google Sheets, you can do it in Numbers, whatever method you would like in terms of setting it up. Just so you know, there is a mod function in the spreadsheets. The problem that we run into, however, is the fact that when you get to mod works fine for addition and multiplication, but when you get to exponentiation, things fall apart. It doesn't work very well. A lot of it has to do with the fact that the spreadsheet in the background, if the numbers get too big, starts to do some rounding, and if that happens, it ruins your encryption. It's going to give you nonsensical answers. So just keep that in mind. We'll talk about that in the next video. It's perfectly fine for what we're going to be doing here. We're not using numbers that are exorbitantly large or anything like that. So so keep that in mind. So I'm going to walk you through this particular example. I picked a message, a little known phrase that you may or may not have heard of, to be or not to be. That is the question. Sorry. Anyway, so what I'm going to do is I'm going to turn this into two-letter blocks, okay? Because that makes it a little bit easier to like work with the individual numbers. So I take the phrase to be or not to be, and I break it up into T-O, B-E, O-R, N-O, T-T-O-B, and then E, and I put a dash here because I don't want E to be by itself. I want there still to be two characters here, and so I put a dash since I don't have an extra letter there. Okay, so that's essentially my plain text that I'm going to be converting. And so what I'm going to do is, simplest way to do this is I'm just going to take and assign to each of the letters just the number based on its position in the alphabet. So T is the 20th letter, O is the 15th, so putting them together I get 2015. One thing to kind of notice is that for B being the second letter, technically this is 0205. The 0 drops, so I just have 205 there. But do keep that in mind. Notice the E is 05. So where that's important is then when I get over here to OB, here's my 15 for the letter O, but then 02 is assigned for B. And then what we do is we put, at least in this case, we're using 27 for the dash, being our kind of 27th character. And so each of these has a more or less 4-digit number associated with them. It's just that for the BE and the E dash, the first digit is a 0, so we don't bother writing it there. Okay, so the way we're going to go ahead and look at each of these, let's see, make sure I have all my notes. So when we're going to go ahead and calculate this and encrypt this using addition, the first thing to keep in mind is that our mod number should be big enough that it will accommodate all of the 4-digit numbers. If we put blocks of 3 letters together, we could potentially have 27, 27, 27. So we'd want to have it bigger than that, but we have two-letter blocks, so the biggest number we would have is 27, 27. So I picked 3120 as my mod. It's big enough. I could pick a bigger one. I could pick a slightly smaller one. It's okay. For the key, ideally we want to cause a little bit of wraparound. So the key should probably be at least half of the mod. I mean, I could make the key 3, but that's not going to change very much and probably make it fairly easy for somebody to guess what the letters are in your process. Okay. So essentially what we're doing is we're going to be taking each of these numbers and we're going to be adding the key and then calculating what that value is under the modulus. Okay, so I've done the first 4 over here, And I could do that by hand, but here's where the beauty of a spreadsheet kind of comes in handy, is I can actually just, here's where I can use the mod function. So and again, this is in all spreadsheets. So I can do equals. You always put an equals in before you put in any type of formula inside of a spreadsheet. Type mod, you'll notice it even shows me, hey, there's a mod thing. So parentheses, and the nice part is most of them will also give you something like this and tell you what's going to happen. So the number I want to plug in is actually the sum of this number and the key. So I can just click on this plus this, and then I want the divisor. So comma, that's for my divisor, and now I'm going to go and click the mod. And if I hit close the parentheses, hit enter, 1678 is the result of 2015 plus 2783 mod 3120. Okay, and I can go ahead and do that for the rest of them. I already did, like you see, the last four, but so I'm going to do mod 205 plus the key, comma, the mod. And I get 2988, and last but not least, equals mod, oops, mod 1518 plus the key, comma, the mod. And so now we have all these. And so this is the number that you would send. Okay? And the way we would decrypt it is we would basically just add the additive inverse. And it's easy to find the additive inverse. You just basically, it's the mod minus the key. So we can do that really quickly. Mod minus key. So that number is 337. So I'm just going to do it for the first one so you can see it. So if I decrypted it, I would essentially equals mod of now this number plus the decryption key, which is our additive inverse, comma, the mod. And notice I get my 2015 back again. Okay, so that's what I would do to go ahead and do that. Okay, so that's the additive one. And I do want to point out, like, you can use, like, you could program this in Scratch. Desmos has a mod function. You can even use your just use your calculators for all this. You could even write programs for it. If you like, you know, if you're into programming and you want to set it up that way, you could totally do that as well. Just, you know, I would say do what makes the most sense to you when you're calculating these. But just a reminder, when we get to the exponential one, we have to be careful about using the mod function in the spreadsheets because of what I mentioned. So then the next thing is, what about multiplication? Well, essentially it's the same process. So you'll notice that I have 4 numbers done already. And so this time, instead of up here, I added them. So you can see the mod is adding the 2 numbers together. This time I'm going to multiply. So I'm going to go ahead and do mod. And this time I'm going to take 2015 and I'm going to do times, which is an asterisk, times the key. Whoops, close the parentheses too soon, and put the mod. Okay, now you'll notice that the key I picked is a much smaller value this time, because the multiplications, when I multiply, the numbers are going to get pretty big fairly quickly, so I don't have to pick a really huge number. It's going to start cycling through, even with a relatively small key. The main thing we want to look at for the key, in order for this to be a decryption, is the key has to be relatively prime with the mod. So remember back to the video where we were looking at multiplicative inverses. In order for a number to have a multiplicative inverse in a particular mod, it has to be relatively prime to that mod. And 7 and 3120 are. So 3120 is fairly easy to find the prime factorization of, so you just have to pick a number that's not going to be a factor of 3120. And obviously 7's a prime number. Obviously not all prime numbers will work, but 7's one that does happen to work in this case. Okay, and again, the whole point of that is because in order to decrypt it, we need to find the multiplicative inverse. So I'm going to go ahead and finish up my mods here. So I'm going to take 205 and I'm going to multiply that by my key and do the mod. Now, some of you might be going, can't we just like drag and drop or copy and paste? There are ways to do that on spreadsheets that make it really quickly, where I could have just put it like in here and then just dragged it for all of them and it would populate it quickly. That's not the point of this video. So I'm not going to worry about it. If you want to know how to do it, I'd be more than happy to explain it to you or show you or create a video if that would be helpful. But it's not the point of what we're doing right now. So then I go ahead and multiply by 7, mod 3120, and so there's all of our numbers. So these numbers are now based on multiplication using the modulus. Okay, so what we did is we took each of these numbers up here, multiplied them by 7, and then calculated what their answer would be in mod 3120. Now, to decrypt it, and you really should check this, because as you're doing these messages, if you do this part incorrectly, you may send a message that you intended, and the person may, if you give them a different key, they may decrypt it just fine. But if you haven't done the work correctly, then the problem is that their message, it won't make sense to them. So you want to make sure you check it. So how do I know 1783 is the multiplicative inverse of 7? Well, we know how to do that. We can use the Euclidean algorithm. We can use the Royal Road to get ourselves there. So we can calculate that. We know how to do that. I can check it right now just to make sure by saying mod of 1783 times 7, comma this, and it equals 1. So that's my check to know that I have the right number there. Okay, but you should be able to calculate that number on your own. So again, I'll go ahead and do the same thing here. Mod. This time when I multiply, I'm taking this number, the cipher number, and I'm multiplying it by my decryption key. But I'm still using the same mod. When I hit enter, notice this is 2015, and that's where it should be when I finish. And so I'll do the same thing here. So my ciphered number times the decryption key, mod, and 205, great. Let's make sure one more. Cipher times decryption, comma, mod. And there we go, 1518. So we've checked to make sure that this does come back to the original message up there. So just make sure it works. Anything else I want to make sure that I think about? No, that pretty much explains what you need to know for at least this basis of modular encryption. So yeah, if you have questions, let me know.